All right, first algebra video for the year. We're going to do a quick review on how to solve two-step equations, and conveniently enough, this aligns with one of our new Common Core standards, solving linear equations and inequalities in one variable. Obviously, this would only be the one part of it. It would be the linear equations, and we'll get to inequalities later. So, a couple things that I really want to go over here. Two ideas: additive inverse and multiplicative inverse. These are going to be key ideas. They're the general idea of how we're going to solve these equations. And ultimately, what an additive inverse is what you add in order to get zero. It's sort of what you're going to do to cancel out something on one side of an equation. So, for instance, let's say I have 5, the number 5. What would be the additive inverse of 5? Well, I would add -5, and then I would get 0. If I have -7, what would be my additive inverse to that? Well, for the opposite of down 7, right, to get back to 0, would be to add 7, okay, or +7. And really what you're trying to do here is you're sort of going back to 0. Another way of looking at 0 is starting point. And this can work for anything. It can work for fractions, decimals. Let's say I have -4.17. What would be the additive inverse of that? Like what would I add to that to get back to 0? Well, you just add 4.17, and it gets me to 0. Okay? That's the general idea. And typically what we'll do is when we solve equations, we'll look for additive inverses first, and then we'll look for the second idea, which is the multiplicative inverse. Well, multiplicative inverse is what we do to multiply to get 1. Now, if you think about multiplying and dividing are just sort of opposites to each other. So even when you're dividing, you're going to use a multiplicative inverse in order to get rid of that. Okay? So, and if you remember from dividing fractions, in order to divide fractions, you actually end up multiplying by the reciprocal, right? Which is the flip. So let's say, if you're taking 4 and you divide by 2, that's the same as saying 4 times, right? Flip that, change it to multiply, 1/2, okay? And you end up with the same thing. 4 divided by 2 is 2. 4 times 1/2 is 2, okay? So that's the general idea there, all right? Why when you divide you're going to use the multiplicative inverse also. And so let's say I have 6, okay? So what do I multiply 6 by to get to 1? So what I'm looking for is how do I get this to 1? Well, I know that if I divided by 6 I would get 1, so I'm going to multiply by 1/6, okay? And that would get me to 1. Let's say I have -7, okay? What would I do to get to 1? Well, my multiplicative inverse is going to be -1/7. Right? Negatives cancel out, get to +1, and my 7s will get to 1. Okay? Let's look at another one. Let's say I have 3 halves. Okay? What is the multiplicative inverse of 3 halves? Like, how am I going to get that to 1? It's going to get multiplied by 2/3. Okay? And if you multiply straight across, you get 6/6. Okay? Let's take a look at another one. What about -1.2? What would be my multiplicative inverse there? Again, what I can do is I can just multiply by -1/1.2. Okay, we could turn this into a fraction if we want, divided by that way. But really, I mean, if you take a look at this, you have -1.2, right? How do you get to 1? You divide by the same thing, right? You divide by -1.2, which is the same as multiplying by -1.2. Or -1/1.2. Okay, so that's the general idea of what we do with these inverses, okay, and we're going to use those to solve problems. So if I have a pretty basic problem here, 3x minus 7 is 14, I want to know what x is, okay? So what we do is we look at this and we say, okay, we'll multiply by 3, and then I subtract 7, it gets me to 14. I'm going to use my additive inverse first here. So I have a -7, so how do I get rid of this -7? How do I make it into 0? Well, what I'm going to do is I'm going to add 7 to it, right? And the general principle is if I add 7 to the left side, I've increased the left side by 7. So that means I need to increase the right side by 7. So I'm going to say 14 plus 7, okay? And then if I have 3x, I subtract 7, and then I add 7. That gets me back. This cancels out, right? This becomes 0, and I'm left with 3x is equal to 14 plus 7 is 21. From here, I have multiply by 3 to get to 21. I'm going to use my multiplicative inverse. So I'm going to have 3x, okay? And I'm going to multiply this by 1/3 is equal to 21. It's the same thing as dividing by 3, okay? The idea is 3. I'm multiplying by 3. So my multiplicative inverse is what I'm going to get to 1, because I want to know what one of these x's is worth, right? So 3 divided by 3, or 3 times 1/3, is going to give me 1. So I'm going to get x here. And that's the same as taking this and multiplying by 1/3, okay? And then 21 times 1 is 21. 21 divided by 3 is 7. So I have x is equal to 7, okay? That's the general idea of using the additive inverse and the multiplicative inverse. So let's do this. Go ahead, take a look at this one. And really what all I want you to do is I want you to identify what is going to be the additive inverse here, and then what's going to be the multiplicative inverse. Okay? And in this case, go ahead, pause the video, see if you can figure it out. All right, so my additive inverse here is going to be, I'm going to add -9, and then my multiplicative inverse is I'm going to multiply by 1/2. All right, so those are the steps that I would do. I'm going to say, okay, I'm going to subtract 9, so I'm going to do 1 plus a -9 is equal to 2x plus 9 plus a -9. Okay, those cancel out. 1 and -9 make -8 is equal to 2x. Multiply by 1/2, so -8 times 1/2 is equal to 2x times 1/2. Okay, these are my inverses. I'm going to end up with x here. What's half of -8 is -4. And there we have it. Okay? General idea, we've done this before, just a little bit new vocabulary. Why don't you go ahead, you try doing this one. I really want you to identify the additive inverse, the multiplicative inverse, and then to go ahead and use those to solve the problem. Once you're done with that one, go ahead and try this one as well. Do the additive inverse, the multiplicative inverse, solve, and we'll talk a little bit more about this in class. Okay, have fun.